Hello friends, welcome back to Survival Roots. Imagine walking into a basement in Lancaster County, Pennsylvania, while a brutal winter storm is still howling outside. The power grid has been dead for 2 full days. The streets are dark, most homes are cold, silent, and waiting for the utility company. But inside this one house, everything still works. The lights are on, the freezer is humming, the well pump still brings water to the sink. And if you care about practical building, affordable materials, off-grid systems, family security, and smart choices before disaster strikes, this is the kind of setup that gets your attention. So you look for the usual answer. A loud gasoline generator? Not here. A huge expensive wall of lithium batteries? Not here either. Instead, tucked quietly in the corner, there's a heavy wheel spinning in the dark. No smoke, no fuel cans, no roaring engine. Just a simple mechanical idea, storing enough energy to carry the home through the night. And here's what makes it fascinating for builders, homesteaders, rural homeowners, DIY thinkers, and anyone who wants strong systems without wasting money. This wheel is not built around rare chemicals or fragile battery cells. It is built around one of the most familiar materials in construction, concrete. Today we are looking at a breakthrough in home energy storage, the domestic flywheel. It takes an old mechanical principle and combines it with modern engineering from France to challenge the high cost of lithium-ion batteries. This solar storage flywheel can reduce the material cost of storing solar energy by up to 95%. Even better, it can work without the electrical grid. So if you want to understand how a spinning block of concrete could help secure your home's energy future for decades, stay with me. And if you value practical construction knowledge, smart materials, resilient homes, and affordable self-sufficiency, make sure you subscribe to Survival Roots before we dive deeper. Part 1. The Energy Trap. Why lithium-ion breaks our hearts and wallets. To understand why this domestic flywheel matters, we first have to understand the trap so many homeowners are being pushed into. Right now, the world is rushing towards solar panels, wind power, and cleaner energy. And for good reason. The sun gives us free power during the day. The wind can produce energy without fuel. But every builder, homesteader, and practical homeowner knows the same hard truth. The sun does not shine at night, and the wind does not always blow when you need it most. So the modern energy industry gives us one main answer: buy lithium-ion batteries. And yes, lithium batteries are useful. They are compact, they are familiar, they are already inside our phones, tools, cars, and many home backup systems. But when you step back and look at the full cost, especially from the point of view of someone trying to build a strong, affordable, long-lasting home, the numbers start to hurt. In 2026, a typical 10 to 13.5 kilowatt-hour home battery system can cost anywhere from $10,000 to $16,000 fully installed. That is not a small upgrade. That is the price of a used vehicle, a serious roof repair, a well system, or a major improvement to your property. And here's the part many companies do not like to put front and center. Lithium-ion batteries degrade. Every time you charge them and discharge them, the chemistry inside changes a little. Slowly, quietly, they lose capacity. A standard lithium-ion battery may last around 3,000 to 6,000 cycles. Many systems also lose capacity year after year. And after 10 or 15 years, that expensive battery wall may no longer perform the way it did when it was new. So we have to ask a serious question. Are we truly independent if our energy security depends on replacing a $15,000 battery system every decade or so? And the problem is not only financial. Lithium, cobalt, and other battery materials come with environmental damage, difficult mining conditions, global supply chain risks, and geopolitical pressure. For people who care about land, homes, family, and long-term resilience, this matters. We do not just want a system that works today. We want a system that still makes sense 20 or 30 years from now. We want energy storage that does not lock us into endless replacements, chemical waste, fire concerns, and rising material costs. There has to be a better way, and to find it, we are going to look backward before we move forward. The Amish secret and the mechanics of the steering wheel. Long before solar panels covered rooftops, people already understood one of the most dependable forms of stored energy: Motion. Think about an old watermill turning beside a creek. Think about a potter's wheel spinning after one strong push. Think about a heavy stone wheel that keeps moving because its own weight and momentum refuse to stop immediately. That is not magic. That is kinetic energy. And this is the same basic idea behind a flywheel energy storage system. A flywheel is simply a heavy rotating mass. When your solar panels produce extra electricity during the day, that electricity powers a motor. The motor spins the wheel faster and faster, converting electrical energy into mechanical energy. Instead of storing power inside chemical cells, you are storing it in motion. Then, when the sun goes down and your home needs power, the process reverses. The spinning wheel begins to slow down. The same motor acts like a generator, turning that stored motion back into usable electricity for your freezer, your lights, your well pump, or other essential systems. For anyone who understands construction, this idea feels familiar. It is strong, it is physical, it is easy to visualize. No mystery box, no delicate chemistry, just mass, rotation, bearings, and a generator. And this is not a new fantasy. Back in 1978, the U.S. Department of Energy and Sandia National Laboratories studied the idea of using rotating mass to store energy for rural homes. The concept showed real promise, especially because mechanical storage could potentially cost far less than chemical battery systems. So why did flywheels not become common in every garage and homestead? The problem was speed. Traditional flywheels often needed to spin extremely fast to store enough energy, sometimes reaching tens of thousands of revolutions per minute. At those speeds, the forces trying to tear the wheel apart are enormous. If the material is not strong enough, the rotor can fail violently. That meant engineers had to use advanced materials like aerospace-grade carbon fiber or high-tensile steel alloys. These materials are powerful, but they are expensive. Carbon fiber, for example, can cost far more than ordinary construction materials like concrete. So the old flywheel idea worked in principle, but for the average homeowner, farmer, builder, or off-grid family, it was simply too costly. Until engineers asked a different question. What if the secret was not spinning a light material insanely fast, but spinning a heavy, affordable material in a smarter way? Part 3. The Concrete Breakthrough, the Voss Innovation. Now we arrive at the breakthrough that makes this entire idea practical for real homes, real builders, and real budgets. A French company called Energiestro looked at the old flywheel problem from a completely different angle. Instead of asking, how do we make an expensive, lightweight rotor spin faster? They asked something much smarter. What if we use a very heavy, very cheap material and spin it at a slower, safer speed? And that question led them to one of the most common building materials on Earth: concrete. For anyone who has ever poured a slab, built a footing, repaired a foundation, or priced construction materials, this makes immediate sense. Concrete is heavy. It is affordable. It is available almost everywhere. It does not depend on rare minerals shipped across the world. It is a material builders already understand. But concrete has one major weakness. It is excellent under compression, which means it can handle being squeezed. That is why it works so well in foundations, columns, walls, and structural pads. But concrete is weak under tension. If you pull it apart, stretch it, or expose it to the wrong kind of force, it can crack and fail. And when a heavy concrete wheel spins, centrifugal force pushes outward in every direction. A plain block of concrete would not survive that stress. It could crack, break apart, or shatter. This is where the engineering becomes brilliant. Energiestro developed a system called Voss, which stands for Solar Storage Flywheel. Some media have described it as a domestic steering wheel, but the real idea is a concrete flywheel designed to store solar energy. To make concrete strong enough for this job, they use a construction principle called pre-stressed concrete. The concrete cylinder is wrapped tightly with high-tension material, such as steel wire or glass fiber. That wrapping places the concrete under constant compression before the wheel even begins to spin. So when the rotor starts turning and the outward forces try to pull the concrete apart, those forces must first overcome the tight compressive pressure already built into the structure. In simple builder's language, they are using pressure to protect the concrete from the kind of force it hates most. That is the genius of it. A basic, affordable construction material is transformed into a high-performance energy rotor. And because concrete is so much cheaper than carbon fiber, the storage medium can reduce capital material cost by up to 95%. This is not just clever engineering. It is the kind of practical thinking we respect at Survival Roots. Take a proven material, understand its strengths and weaknesses, and design the system around reality instead of hype. Part 4. How it works without the grid. Anatomy of the beast. Now, if you are thinking like a builder or a practical off-grid homeowner, you are probably asking the right question. If this wheel is spinning for hours, won't friction slow it down and waste the energy? That question matters because in any mechanical system, friction is the enemy. It steals power, creates heat, wears out parts, and reduces efficiency. So Energy Stro had to solve that problem carefully. The concrete rotor is placed inside a sealed vacuum chamber. By removing the air around the spinning wheel, the system removes almost all aerodynamic drag. There is no air pushing against the rotor, no wind resistance fighting the motion, and no constant energy loss from the wheel cutting through air. That is one reason the system can reach operating efficiencies of around 85% to 95%. But then comes the next challenge. Weight. A residential concrete flywheel capable of storing around 10 kilowatt-hours of energy can weigh several tons. That is not something you support with ordinary hardware and hope for the best. If you put that kind of load on standard ball bearings, they would wear down quickly under the pressure. But fully active magnetic bearings, while impressive, are usually too expensive for a practical home energy system. So Energy Stro developed a hybrid bearing solution. A passive magnetic thrust bearing carries much of the heavy vertical load, almost like it is lifting the weight of the flywheel without constant contact. Then standard ball bearings are used to keep the rotor centered and stable as it spins. This combination helps reduce wear while keeping the system more affordable than a fully magnetic industrial setup. They also developed a special lubrication system designed to function inside the vacuum environment, because ordinary lubrication methods are not always suitable when air has been removed. Then, connected to the rotor, you have a bidirectional motor alternator. During the day, when your solar panels produce extra electricity, it works as a motor and speeds up the flywheel. At night, or during a blackout, it works in reverse as a generator, converting that spinning motion back into electricity. An electronic converter then takes the changing electrical output from the spinning system and turns it into stable, usable power for the home. That is how this system can operate without the grid. No utility company has to be present. No fuel truck has to arrive. No noisy generator has to roar behind the house. It is a self-contained mechanical energy system. Solar power in, spinning mass in the middle, usable electricity out when your home needs it most. Part 5. The Ultimate Battle, Concrete Flywheel versus Lithium-ion. Now let's place these two technologies side by side and look at them the way a practical builder would. Not by hype, but by lifespan, durability, safety, and long-term value. First, lifespan. A good lithium-ion home battery may deliver around 3,000 to 6,000 charge cycles before its performance drops significantly. That sounds impressive until you compare it with the Voss concrete flywheel, which is designed for more than 100,000 cycles. You can charge it, discharge it, and repeat that process many times a day without the same chemical wear that slowly weakens a battery. There is no internal chemistry breaking down every time you use it. For a homeowner thinking in decades, that difference is enormous. Second, temperature. Lithium batteries do not like extreme heat or extreme cold. In many systems, they need to stay within a controlled temperature range, often around 0 degrees Celsius to 45 degrees Celsius. In hot climates, that may mean spending extra energy just to cool the batteries and protect them. A concrete flywheel is far less sensitive. Because the rotor is isolated inside a vacuum chamber, it can operate in much harsher conditions, from deep cold to temperatures well above what most battery systems prefer. Third, depth of discharge. With chemical batteries, you usually avoid draining them completely because deep discharge can shorten their life. Many systems are designed around using only 80% or 90% of the stored energy. A flywheel is different. you can slow it all the way down and use 100% of its stored kinetic energy without damaging it. The next time the sun comes out, you simply spin it back up again. And then there is safety. Lithium batteries carry a real risk of overheating, thermal runaway, and chemical fire. A concrete flywheel has no flammable liquid, no toxic battery chemistry, and no chemical fire hazard. For people building resilient homes, workshops, homesteads, or off-grid cabins, that safety advantage is not a small detail. It is one of the biggest reasons this technology deserves attention. Part 6. Real-world proof. From French Guiana to your garage. At this point, the natural question is simple. Is this only a clever laboratory idea, or is it already being tested in the real world? The answer is that it is very real. Voltalia, a major international renewable energy producer, partnered with Energistro to deploy a 10 kilowatt-hour VOS prototype at the Toko storage complex in French Guiana. That location matters because French Guiana is hot, humid, and demanding, exactly the kind of environment where chemical batteries can struggle. The flywheel was used to provide fast, sustainable energy storage and help stabilize the local grid. Engie has also adopted the technology for its Thémis Experimental Center in the Pyrenees, where it has been used for grid frequency regulation. That means this is not just a backyard experiment or a concept drawing on paper. It is industrial engineering being tested by serious energy companies in serious conditions. The technology has also gained recognition through the EDF Pulse Award in the science category, which shows that larger players in the energy world are paying attention. So when we talk about a concrete flywheel for home energy storage, we are not talking about science fiction. We are talking about a field-tested idea moving from large renewable energy sites towards smaller, more practical systems. And for anyone who cares about affordable construction, strong materials, off-grid resilience, and long-term self-reliance, that makes this one of the most interesting energy storage breakthroughs to watch. Part 7. Building for resilience. What this means for Survival Roots. At Survival Roots, self-reliance is not just a nice idea. It is the foundation of a stronger home and a more stable life. Real resilience means stepping away from fragile systems that can break when prices rise, supply chains fail, or the grid goes down. Look at chemical batteries. They depend on lithium, cobalt, and nickel, materials often mined far from home and tied to global shipping, tariffs, political pressure, and environmental damage. Now compare that with the concrete flywheel. This is energy sovereignty in practical form. Concrete is made from aggregate, cement, and water. These are familiar materials that can be sourced in many regions without rare minerals. The steel wire and housing are also standard industrial materials. And after decades of use, when the system reaches the end of its mechanical life, you are not left with toxic waste. The steel can go back to a foundry, the concrete can be crushed and reused as gravel or construction fill. That is long-term sustainability, local, strong, recyclable, and built for generations. Body Part 8. Setting up your own system. Practical takeaways. So what does this mean for your own home, cabin, workshop, or homestead? First, installation has to be treated seriously. A 10 kilowatt-hour concrete flywheel may be about the size of a large household appliance, but it can weigh several tons. This is not something you bolt to a wall or slide into a closet. It needs a dedicated, stable concrete pad, possibly in a garage, utility shed, equipment room, or even a partially buried structure for extra safety and sound control. But before you start thinking about any storage system, remember one old rule from serious off-grid builders. Never build a massive system just to power a wasteful house. First, reduce the load. Improve efficiency. Know what truly matters during the blackout. For most families, the critical needs are simple. Water from the well pump, a freezer to protect food, basic lighting, communication, and maybe a few essential tools or medical devices. This is where flywheels become especially interesting. Heavy loads like well pumps, compressors, and air conditioning motors often need a sudden surge of power when they start. That surge can stress or trip a standard battery system. A flywheel, with its stored kinetic momentum, is naturally good at delivering these short, powerful bursts. For the most practical home setup, a hybrid system may make the most sense. A smaller lithium battery can handle quiet, steady loads like LED lights, a router, or electronics overnight. The Flywheel can handle the heavy work: motor startups, rapid cycling, and power spikes. Used together, the Flywheel reduces stress on the battery. The battery covers the small continuous loads, and the whole system can last longer while staying more reliable. We live in a time when companies constantly try to sell us the newest, most expensive black box and call it freedom. But real freedom is not always shiny. Sometimes it is heavy, simple, and built on a solid foundation. The concrete solar storage Flywheel is more than another energy gadget. It is a return to common sense. It takes one of the oldest mechanical ideas, a spinning wheel, and combines it with one of the most trusted building materials on Earth: concrete. The result is a system that can challenge lithium batteries in cost, lifespan, safety, and long-term sustainability. For builders, homesteaders, and homeowners who want practical resilience, this matters. We are not just talking about saving money. We are talking about building homes that can keep water flowing, food frozen, lights on, and families safe when the grid fails. Now I want to hear from you. If the power went out tomorrow and you had a concrete Flywheel in your garage, what are the top 3 things you would choose to power first? Your well pump? Your freezer? Your lights? Tell me in the comments, because every resilient home begins with clear priorities. If this kind of knowledge helps you think differently about building, energy, and self-sufficiency, hit the like button, share this video with someone who loves off-grid technology, and subscribe to Survival Roots. Until next time, build deep roots, build wisely, and stay resilient.